work from 48 to 50. That's not out.
You think?
That's not out, but
That's your brain. My brain doesn't work.
Today is the 23rd, and we're going to learn something today.
we did the school song right after somebody cheated and won.
It was very nice, but threes. Why would I come live in the see or the ghetto of Alvin?
So I'm not even going to give you your new assignment today. Take that. We're going to work here for 15, 18 minutes, and then we're going to just leave in peace. My goal is that when you leave here in 15, 20 minutes, that you know how to determine if two functions are inverses of each other. And that maybe if I clumsy my way through the explanation of why does this actually work, maybe you'll buy into it and see why the results that we look for are the results that we look for. Like, that's the goal. I don't know if we'll get there, but that'll be the plan. So we're going to go back to something that we did. And I don't know, a lot of teachers may not start the lesson this way, but I'm actually going to come up with a function. We're going to find the inverse of the function. And so there's going to be no one there to say, gosh, I wonder if those are inverses, because we're going to like literally be the ones who find the inverse. But I want to use this as an example to maybe help you have some buy-in as to the fact that like there's some legitimacy to this process that we're going to go through today. So we're going to do a nice simple function. Now I'm talking like super easy. We're going to do a function like f of x equals 3x minus 4. Like just simple. And they're not always going to be this simple, but I thought for the illustrative purposes here, let's just keep it simple. We'll worry about all the big fancy stuff for the later problems. So that's the function f of x. Our goal is to find, remember, we call it f inverse of x. And you guys remember the process? We kind of got off track for a couple of days, but remember when we were doing this, what the process is? Yeah, switch the x and the y. So step one is really to take your f of x and just replace it with y. And then we swap the variables, you'll recall. So now the equation, when we do the inverse swap, zoop, we say now that the equation is x equals 3y minus 4. And what do we do after this? Yeah, we resolve now, right? We get back in algebra 1 mode where we say get y by itself, get y by itself. So we're going to add 4 to both sides. So we're going to have x plus 4 equals 3y. And then what are we going to do? We're going to divide by 3. So we're going to wind up being able to say now that y equals x plus 4 over 3. Got it? So I'm gonna change colors maybe here or something, but I want to draw your attention now to sort of where we're at in the process. We are now we had an original function. His name was f of x, and he was 3x minus 4. And we have now discovered another function. His name, remember, is f inverse of x, and he is x plus 4 over 3. You cannot take this particular class, like if you took it at LCCC or if you any sort of pre-calculusy kind of class, you cannot get out of it without knowing how to test two functions to see if they're inverses. Now, there is a way to do it graphically. It's pretty clumsy, but algebraically, there's a process that we go through. And what we're actually going to do, I'm going to show you that process, is we're going to compose the functions with each other. And we're looking for one very particular result. So what I mean by that, we did a little work on this at some point. I don't remember what day it was, but we're going to compute two math problems. We're going to first compute f of f inverse of x, and I'm going to draw like a little dividing wall down the center. But these are bidirectional. In order for two functions to be inverses, you have to compose them both ways. We have to do f of f inverse of x, but we also have to compose it the other direction. We have to compose f inverse with f of x. And if it would make you feel better, like for your notes, maybe if your brain's hurting a little bit right now, you can think of these like as f of x and g of x. No harm at this point, because really what we're after is just there are two functions on the board, and we want to know if they're inverses. And again, there's no secret to this. We already know they're flipping inverses because we did it ourselves. But I just want to show you the process, because today or tomorrow's assignment is going to be all about, here are two functions, f of x and g of x. You determine if they are or are not or inverses of each other. Got it? So there is no foregone conclusion normally. This one, the cat's out of the bag. So let's do it. So to do the composition in the forward direction, to do f of f inverse means to do this. We're going to take the red function, which is 3x minus 4. But since we're doing a composition, what are we going to put in there? Very good. So this is what the composition looks like in this direction. Okay. Now I'm going to do the other one over here before we do the actual math. The math on these is what gets sticky. But let's do the other direction. Let's do f inverse of f. Going the other direction, it will be this. It will be x plus 4 over 3. And what am I going to put in that blank? Good job. And I'm trying to color code this. I don't know if you pick up on these little things, but I'm trying to show you how red goes into purple in one of them and how purple goes into red in the other one. Now, what we have to do is we have to but simplify both of these calculations. And you will notice that both times we get a very particular answer. And from that, then hopefully you'll be able to say, okay, so this is what's true. If I make the composition in both directions and I get this as my answer, then I can say yes. And then again, I will clumsily try to explain to you why this works. And if that fails, then it may not be the right time yet for that explanation. So we'll see. Yeah, it's not the right day. I just talked myself out of it. No, we got to do a little graphy stuff before the explanation makes sense. So I talked myself out of it. Let's get to it. Let's do the math. I just had a whole conversation with myself. I apologize for that, but it's not the right day. I decided. So let's look at the first problem over here on the left. This is just now back to math. We're not in pre-calculus advanced math right now. We're just going all the way back to the good old days. If I said simplify that expression, what's the first thing you'd do? I wouldn't. I mean, kind of, but keep it simple. What do you see? There's no equation here. How about this one? What if I gave you 5 times k over 5 minus 3? And I said, just work with me here. Figure out what that equals. Do you notice anything?
Do you remove the division? Like, not that. But
You mean, are you trying to say that these 5s could maybe cancel each other out?
Yeah.
I agree. So remember, we're not solving any equation here. All I'm asking you to do is clean house a little bit. And I'm sorry that you didn't understand my question, but keep it simple. All I'm asking you to do is take this expression over here and make it better. And I think you would agree that a times 3 and a divide 3 are inverses, correct? Like we've known that since like way back in the day, before I met you. So this 3 and this 3 are going to cancel each other out. And then the top of the fraction just drops right down and it becomes x plus 4. And then, of course, minus 4. And then let's keep going. Let's keep simplifying. What happens? The 4s cancel out, and our answer is very specifically something that you're going to come to appreciate, x. But that's half the battle. Let's go the other way. Let's do the composition or the simplification coming from the other direction. So this time we're going to take this one, and this one, the order of operations behaves a little bit differently on this side. First off, these parentheses that I have drawn in purple, those are just cosmetic. Like they don't serve any purpose. I put them there for illustrative purposes so you could like see the physical location where the composition happens, but really they serve no purpose. There's nothing in front of them. And what do you see now? Order of operations. What does it tell you to do? Cancel the 4s, did you say? The 3s don't go yet, but the 4s do first because the 4s are both in the top. So like order of operations would say, like you got to do the whole top of the fraction first before you can divide. So I'm going to take the minus 4 and the plus 4 on top, and I'm going to say Goodbye. You're out. That leaves behind 3x over 3. And now you can cancel out the 3's. And hey, guess what we got? In case you didn't crack the code, here it is for your notes. If two functions are inverses of each other, when you compose them in both directions, you will get x for your answer. And again, I'm so like just fighting every urge I have to show you why that is, but not today. So that is what you need to know. So when you compose f with g, and then you compose g with f, if both times, both directions, the answer is x, then you can say these two functions are inverses of each other. Let's do another one. So the answer is, well, I mean, we knew what the answer was, but we proved it. So here's a function named f of x. And let's do like the quantity of x minus 4 squared minus 3. Okay. And this will be another one where there's no secrets about it. We're going to find the darn inverse ourselves. So it's not like we'll wonder what's going on. Let's find his inverse. So there he is, right? We got this. This is a little bit tougher than what we're used to. We're not scared. And so I'm going to replace f of x with y, and then I am going to switch their locations with each other. So my new equation is going to be x equals the quantity of y minus 4 squared minus 3. And just follow your instincts here. To get that new y by himself, what would you do first? Yes, whispering add 3 is perfect. Listen, this squared thing in the parentheses right now is an untouchable chunk because of the minus 3. That minus 3, you've known since like 7th grade. Those hangy-yanny numbers like that, they got to go. So we're going to start by adding 3 across to the left. We're going to get x plus 3 equals the quantity of y minus 4 squared. It's time now to do what we want to do. How can I get y to the point where I could solve for him? Correct. Your target right now should be saying, I need everything that's written in red to go unalive itself, right? Because that's what's keeping my y and my minus 4 from being able to move around. So what we're going to do now is we're going to take a square root on both sides of the equal sign. Anything in math can be undone. Squares can be undone with square roots and vice versa. So what I'm left with now is on the left-hand side, I'm left with the square root of x plus 3. And on the right side, I'm left with y minus 4. Got it? But I'm not quite done. What's the last step to get y by himself? Let's add 4. So our final statement is that y equals the square root of x plus 3 plus 4. And now I'm going to, again, package it up for you into red and purple, and we're going to do our thing. At this point, we can say, okay, there was an original function named f of x, and he was, you'll recall, the quantity of x minus 4 squared minus 3. And this time, to make it a little bit, maybe I'll give you like a different perspective. Some of you might like it, some of you might not. I'm just going to call the inverse function g of x, because we're going to go into make-believe land and pretend like we don't actually know that these are inverses, like we didn't do it ourselves. Okay, so we're going to call the other guy g. And what's g of x? Sure. Plus 4, right? Any questions so far? Okay, so what we're poised to do right now, and I can do this, I don't know how quickly or easily, you probably don't actually want to do this. You probably want the work in your notes. But where I'm at with you right now is this is what a homework problem will look like. You're going to be given two functions like this, and you're going to be asked the question, are they inverses? Well, let's find out. And how we find out is by doing, again, that bidirectional composition. So we're going to go in the first direction and find f of g of x. And then I'm going to draw a wall. And on the other side of this curtain wall, what's the other composition we're going to do? G of f of x. And what are we looking for the answer to be on both sides of the wall? If we can get x when we're simplified, then we can say, did it, proved it, they're inverses. If one of them turns out to be x and the other one doesn't, that's not enough for us. They're not inverses. All right, so let's look at f of g of x first. So what this is going to look like is blank. I just gotta be careful how I do this. Blank minus 4 squared minus 3. I think that worked out okay. So where they used to say x in the red function, I just took it out. What's going to go in that awkward void? The square root of x plus 3 plus 4. So that's a lot to digest there. It looks a lot messier than it actually is. And again, I see a pair of parentheses. I'm gonna turn them yellow for you so I can just point them out. Turns out that these yellow parentheses really don't serve a purpose. You would agree. So if it makes you feel better, you can omit them. They're not doing anything in this case. Do you notice anything rad happening inside those red parentheses? I see 4s that are going to cancel out. And then I see that if I simplify this down a little bit now, I'm left with the square root of x plus 3 squared minus 3. What happens when I square that square root?
Yeah.
I just get x plus 3. And what's x plus 3 minus 3? Hey, surprise, surprise. We got x. Let's see if we can't, in these last 2 minutes and 15 seconds, do the composition the other way. And then we'll leave in peace. So the other direction is g of f of x. And so I'm going to copy down the function named g. I'm going to put a square root and with a little plus 3 inside of it like this, and then a little plus 4 at the end. And notice I've left room where x used to be. And what am I going to put where x used to be? You bet. I left a pretty good amount of room there. I called it. And what rad thing happens inside the root? They do, right? Sometimes these things just, man, they're meant to be. And when those 3's cancel, we're left again looking at something that I hope is obvious. What happens when the purple square root sign and the red exponent collide? They do perfectly cancel. We're left with x minus 4 plus 4, which equals x. So I wish I had a little more time with you, but that's the gist of it. Tomorrow, I'm going to be giving you a worksheet. You're going to compose f of g. You're going to compose g of f. The good news is this: if you do one of the compositions and it doesn't work, then you don't have to do the other one. And there's some that we'll talk tomorrow. Some of them are obviously not inverses. I considered taking them off and decided not to. So yeah, that's that. What'd you say?
So,
Nice.
those things.